Okay, hey everyone. Let's hope that my recording has audio today, because it's late at night again, and I do not feel like, having to retake this if it doesn't work. So today we are doing an Are Angles Enough Desmos. So on Friday, we did an activity where you were testing to see different, if two polygons were similar using angles and corresponding sides. We learned that in order to tell whether a polygon is similar, the angles will always, always, always be the same. If you have similar shapes, they will always be the same. And if uh, the other thing you had to pay attention to was the side length. So here's those notes from um, Friday. So corresponding angles have to have the same measure. But then you also have to have a single scale factor. If you do not have that scale factor, if the scale factor between sides are not the same for every side, then it's not similar. Remember also that similar in math is different than similar in ELA. In ELA, similar means that there is something in common. In math, similar figures means a scale copy. So today our focus is going to be on triangles specifically because triangles are unique. Triangles have their own kind of rules to them because we already learned with a triangle, all three angles in a triangle add up to 180. So these three angles, what is my thing doing? These three angles here add up to 180. But these three angles here also add up to 180. So because of that, there is special rules with triangles um, that makes triangles a little bit easier than other polygons. So we are going to go through this Desmos today called Are Angles Enough together. And then you guys are going to work on a Delta Math or a Blookit or something that I haven't decided yet, maybe a Zern. I really haven't decided what you guys are going to do after this Desmos yet. I'll figure that out when I'm done recording this. So, on slide one here, if everyone can get on to slide one of the Desmos for today. So, remember we did this puzzling out Desmos a couple weeks ago, and you had to reveal some angles, figure out what the other angles are in the puzzle. So I'm going to select this one here, 42 degrees. And then I am also going to select this one here. This cannot be done with only one reveal, um, but it can be done with two. So I did 42 and 87. And I can figure out this third one here because all three have to add up to 180. So in my calculator on the side, I want to do 180 minus this 87, which gives me 93. And I also want to subtract this 42, which leaves me with 51. So this last angle here should be 51 degrees. Now these two up here, we know that these three blue angles should also add up to 180. But notice that these two lines are parallel and we have this transversal. So this angle and this angle are in corresponding parts. They're both below the line and right of the transversal. These two are also corresponding because they're below these two lines and to the left of this transversal. So because these are corresponding, that means this one here also has to be 42. And this one here also has to be 87. So, fun fact with triangles that we're going to continue to explore today is that if you have two triangles like this, that they have this angle in common. So this small triangle has this 51, and this large triangle has this 51. And these two lines are parallel to each other. These angles will be the same as these angles, always. So let's continue to explore that. So are angles enough? This is what we discussed on Friday. I can adjust these shapes here, and it wants us to make ones that have those same angles but are not similar. So if you look at these here, these two are not similar. They have all the same angles, but they are not scaled copies. I can do the same thing with this one. I can make this, these angles here are all the same. They are keeping them the same. If you can't tell, I'll show you how these angles are the same here. Again, not scaled copies. So in polygons, whether they're quadrilaterals, pentagons, hexagons, octagons, anything more than a triangle, automatically you need to know the side lengths as well. If you are just given the angles, you won't necessarily know if it is similar or not. But like I said, triangles are special. So here we are going to see if three angles in a triangle are enough. So it wants us to drag these points in the triangle to make it so that one angle is 40, one angle is 55, and one angle is 85. Please go ahead and make your triangle. Your triangle does not have to be the same as mine. It does not matter how you make your triangle, as long as you have these side lengths. So I've got my 40 here. You again move your triangle however you need to so that you get these three angles. I don't care how you make your triangle, and it will not let you submit. So notice if I change mine, it's not going to let me submit my triangle without those angles. So make your triangle. Hello. Make your triangle so it has those angles. And then this button will appear. So I have made my triangle with those three angles. Yours very well can look different than mine. Notice that this one's different than the first one I made. And it says, do you think all of the triangles that we all made, my triangle, your triangle, the person sitting next to you's triangle, do you think they will be similar? So go ahead, pick yes or no. It's up to you what you want to pick, and we are going to go ahead and explore that. So on the next slide, this is just my slide because I'm not doing it with anyone right now, but yours should have the triangles of the different people in your class. So I'll have a bunch of different triangles in here, and you're going to click try it. Notice it's aligning my points together. So I'm going to just reset this. So I've got these triangles in the different shapes that people could have drawn them, or in the different places, different sizes, but they all have these same angles. It translated to the point was together, rotated them, and then reflected them. So it did all of our rigid transformations from Unit 1. Translation, rotation, reflection. So that they all lined up to have this angle match up. And now I can move my triangle to have a larger or smaller scale factor. And notice I can dilate it. Here's a scale factor of 1.4 to match up with that one. Here's a scale factor of 0.56 to match up with that one. Also notice in all of these, my lines are parallel. This side, oops, let go of the cursor. This side and these other ones are all parallel. And so they're automatically going to be similar triangles. When you have all three angles be the same with a triangle, they will be similar. So this one says to move the points so that one angle is 40 degrees. So it only cares that you make sure one angle is 40 degrees. Again, yours is going to look different than mine. You can make it however you want. Just make sure that one of the angles is a 40-degree angle. Again, it's not going to pop up here until you make sure that one of them is 40 degrees. I've already made 3 different ones that have a 40-degree angle. So make yours however you want. I want to make a specific one. Maybe I won't. I was trying to make one that would be specifically what I wanted. Just for fun, and it's not. I'm trying to make it so I could have 2 40s. But again, that doesn't matter. Make whatever you want. I'm smitten. Do you think all of these triangles will be the same? Again, everyone, the only thing you are making sure of is that one angle is 40 degrees. It does not matter what the other 2 are. Do you think these ones will be similar? Again, go ahead, select what do you think? And we are going to try it. So here are, again, other random ones where one angle is 40 degrees here. You're going to have a whole group of triangles that your classmates made where at least one angle is 90 degrees. Again, it's going to align them up using translations, rotations, and reflections to make sure all of the 40-degree angles align. And we're going to see if they are similar. So translating, rotating, reflecting. Notice now these angles or these lines here are not parallel. So if I use a scale factor to dilate my triangle, I cannot get it to match up with this other big one. And I cannot get it to match up with this other small one. So just because one angle is congruent, it doesn't mean all 3 angles will be congruent. So now I want you to go ahead and take a moment to organize these 5 cards here by whether they are similar, not similar, or maybe it doesn't give you enough information. Are they similar, not similar, or maybe it does not give you enough information? Please rearrange this slide so that you have these 3 at the top to make it a little bit easier when you're sorting your cards. So these 5 cards need to go into these different categories here. Okay. So one of the things that we know is to look like when we are looking at these 2 quadrilaterals. So if I look at my first quadrilateral that are the rectangles, we have the angles that are the same. We automatically know that is needed in order for them to be similar. We also need to know that the side lengths have the same scale factor. So if I'm going from 4 to 2, that is a scale factor of 1/2. Or if I'm going from 3 to 3, that is a scale factor of 1. So that is not similar. Maybe if I tried to rotate this one so that it went from 4 to 3 and then 3 to 2, but that is also still not similar. So because these sides do not have the same scale factor, these are not similar. Looking at this one, our angles are all the same again. We have 45, 135, 45, 135, and then the same thing on the green. However, it does not tell us our sides. So because we don't know whether the side lengths have the same scale factor or not, this is not enough information. So now let's go on to our triangles that we have just been focusing on and talking about. So with triangles again, angles are enough information with a triangle as long as you have enough angles given to you. So with these triangles here, we have 40, 60, 80, 40, 60, 80. I could translate my 40s on top of each other, rotate them, and my 60, 80 line will be parallel to each other. So with a triangle, if all 3 angles are the same, then they will automatically be similar. Again, this is only for triangles. If you have the three angles all the same, then they will be similar. Ah, this won't drag. There we go. Okay, now looking at the 70s. We just did the activity where if we are given one angle, that is not enough information because these two other ones might be different. So if we only have one angle that's the same, it's not enough information to know whether they are similar or not. Man, sorry I keep yawning, guys. Okay, and then our last one here. This one you have to do the math for. Don't be lazy and just look at it. Don't be like, oh, one's 25, one's 45. You have to do the math. So we know triangles have to add up to 180. So 110 plus 25 is 135. So you would have to figure out 135 plus what gives you 180 to figure out this one. On this triangle, you have 110 and 45. So that's 155. So 155 plus what equals 180 for this one. Again, if I pull up my calculator, maybe I do 180 minus 110 minus 25. That gives me 45. So in the blue one, it's saying that this last angle in the blue one should be 45. Let me just double check with my other one. 180 minus 110 minus 45. That equals 25. So this one here is 25. So in these two triangles, we have 45, 110, 25, 45, 110, 25. So the three angles in these two triangles are the same, so these two triangles are automatically similar. Okay, so I already kind of went over this one with you. Are you ready for more? It's asking you, so it says here are two similar triangles. Santino says that in similar triangles, if you match up two pairs of sides at a vertex, then the third sides are always parallel. So if they are similar triangles, you match them up at a vertex, the third sides are parallel. That is what I already discussed with you. So if I match these up, notice these two sides are parallel. If I match these up, these two sides are parallel. And if I match these up, these two sides are parallel. Again, you can try it with other similar triangles and notice that they will always be parallel. That is true. That is a true statement, that they will always be parallel. And that has to do with the parallel lines and transversals that we were working with in Unit 1. So these are corresponding angles if you look at the parallel lines with the transversal. So I could sit here and keep doing this all day long. I will not find similar triangles that don't share parallel lines. So in your thinking, you could say that simply you tested it with different triangles. You could say that the two triangles have corresponding angles that match up with the corresponding angles in parallel lines with a transversal. Or you could say the sample response that Desmos gives. Here is Desmos's sample response. Desmos says Santino is correct because dilations always take lines to parallel lines, and you can show that these triangles are similar through a dilation. So that's another thing that we've looked at and talked about in this unit is dilations. So when you dilate something, the corresponding sides are also parallel. So these are all different things that are true. Obviously, this one's not with mathematical thinking. This is just you testing them. These two are more mathematical thinking explanations. Okay, lesson synthesis. So this is what I want you to figure out. It says discuss with a partner. You don't have to discuss with a partner. It says, are these triangles similar? So notice you've got a 50-60, you've got a 50-60. Are they similar? Not similar, not enough information, and then you have to explain your thinking. So you can use the sketch tool, draw on here if you want. Um, and tell me what you think, similar or not similar, using what we talked about earlier in this video. I then also want you to tell me, are these two similar or not? Again, you can use the sketch tool. It gives you 37 degrees up here and then two right angles. Remember what a right angle is when you have the box, that's a right angle. So what degrees is that? So figure out, are these two triangles similar or not? And this one you can use what we've learned with angles, or you could also use the grid lines and actually try to use proportions. But notice this one's kind of up here a little bit. It's not perfectly on a grid line. So using scale factors might mess you up a little bit. But it's up to you. Use what we've done with angles and stuff earlier in this unit. And then tell me how you feel about this lesson today. So again, this Desmos, I'll be looking for this Desmos to be completed, as you should have been doing it with me in this video. And then after this, I need you to complete either the Delta Math or Bookit or whatever assignment I'm giving you after this. I will figure that out now. If you guys have any questions, just let me know.